graders. We are doing the chapter 1 review. We started without you, but I'll catch you up here. The first 3 problems, we were using the pattern to write the next 3 terms in the sequence. So basically you're looking for common differences or what you add to each term to get to the next term. So in the first one, it was the difference of 6, so we just continued going up by 6. The next one, it was decreasing by 4 every time, so we decreased each term by 4. We were just finishing letter C. We had to go up by 20 every time. 75 plus 20 gave us 95. 95 plus 20 gave us 115. And then our next one would be 115 plus 20? 135. Perfect. Okay. In section 1-2, we talked about exponents. Exponents tell us how many times the base is going to be multiplied by itself. So for example, here I would go 4 times 4 times 4. Yep, 4 times 4 is 16, and then 16 times 4 is 64. The next one, I have 9 times 2, so 9 times 9, 81. Now this one's going to be a little bit bigger because we have 7 2's, so 1, 2, 3, 4, 5, 6, 7. I like to group them sometimes. So for example, I know that 2 times 2 is 4. You can just keep going up, so 4 times 2 would be 8 times 2 is 16 times 2 is 32 times 2 is 64 times 2 is 128. Good job, Peyton.
You said 116.
Okay, Maddie, what's your question?
Big brain.
So what we just did,
Yep.
instead of doing what you did, would you get the same answer if you did 2 times 7?
No.
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 'Cause-
2 times 7 is 14.
Yep, very good. So that's a common mistake that people make is they just multiply the exponent times the base, and that doesn't work. So you have to make sure. So
Number G is 7.
you have to make sure that you are.
It's
7 for number G.
Okay, so the next one though, this is kind of tricky. It's not 7 because if you have 7 times 1 times itself 7 times, it's just 1. Okay, the one trick question, anything to the 0 is what?
0.
No, 1. So if I had 10 to the 0, it would be 1. That's just a little fun fact there. Okay, scientific notation.
But you had to put the answer. What about I?
Where?
You got to put H for I. Over
For number I.
across right here.
I haven't done I yet.
She hasn't done number I. Moron.
Where did you? I'm sorry.
Okay, so now we're on section 1-3, which was scientific notation.
I know it.
The first 2, are these values in scientific notation?
No.
No, okay, so scientific notation has to have it kind of like this. It has to be greater than 1 but less than 10. These ones are not, but we can still do this. The decimal is right here. It's an understood decimal with it being a whole number. And then what you're going to have to do is you have to move it in the positive direction 4 times. So I'm going to move it 1, 2, 3, 4.
You'll get,
So then it's going to be 1, 5, 7. I'm going to add 1, 2, 3, 4 zeros and put your commas in there.
So you make that into a big number?
Yep, it becomes a big number.
Big brain.
Okay, the next one, same thing here. We've got our decimal point right here. Because it's just an understood decimal, so then we have to move it to the right 2 places. 1, 4, 4, 0, 0. Throw your comma in there, and that's your answer. Okay. I didn't give any negative numbers on here.
Will it be on the test?
I hope that.
Maybe.
Negative numbers, is it on the back?
Okay. So the next one, it says write in scientific notation. So if the number isn't, this is called standard form, just how we generally write a number. The understood decimal is right there. We have to write it in scientific notation. That means I have to move my decimal to a point where I create a number that's greater than 1 but less than 10. So what two numbers am I going to put that decimal between? Jada, go ahead.
4 and 8.
4 and 8. So you're going to move it to right here. So we're going to count 1, 2, 3, 4. So it's going to be 4.8. You can drop off the rest of the zeros if there's no other numbers. Times 10 to the 4th.
Nope.
Okay. The next one. Please raise your hand and tell me what two digits am I going to put the decimal between? Kamara.
7 and 0.
The 7 and 0 right here. So I'm going to move it 1, 2, 3, 4, 5, 6. So it's going to be 7 point. Make sure that you include the 2 times 10 to the, and we moved it 6 times. Next one, raise your hand if you can tell me what two decimals we're going to move it in between. Lydia, go ahead.
The 1 and 4.
The 1 and the 4. So we're going to move right here. 1, 2, 3, 4, 5. So 1.49 times 10 to the 5, to the 5th. The last one, letter M, it says that we need, in 2006, the population of Switzerland was about 7.507 times 10 to the 6th. Write this population in standard form. So standard form is when we take this scientific notation and we multiply it out. So if I start with that decimal, I'm going to move it 6 places to the right. 1, 2, 3, 4, 5, 6. Some people think that you put 6 zeros on there, but on this one, how many zeros did I put?
3.
Just 3. So 7, 5, 0, 7, 1, 2, 3, and this is people. Okay, so that was section 1.3. In section 1.4, we talked about the order of operations. Remember, that's please excuse my dear Aunt Sally. Remember that multiplication, division, and addition and subtraction, they always work left to right. Left to right. Okay, so in the problem, what would I do first? Peyton. The parentheses. So we're going to do what's in the parentheses first. What's 8 plus 6?
23. That's 18. Wait.
Oh, 18 plus 6, sorry.
Oh, jeez.
18 plus 6. 18 plus 6. 24.
Told you, bud.
I said it, bud.
You said 23.
I said 24. I'll take
Okay.
my answer after that.
Oh my gosh.
Okay, the next thing that I'm going to do, am I going to subtract or am I going to multiply? Jaden, multiply. So I need to multiply. Kind of made it hard to see. So 24 times 5. You could do this off to the side if we need to. I also like to think about it. 25 times 5 would be 125. And then you're going to take 5 off of that. Otherwise, you can just do it like this. And you get 120. 150 minus 120 is 30. Okay, the next question. Raise your hand if you can tell me what I need to do first. Lauren, go ahead. The parentheses. So we're going to start with the parentheses.
3.
Yep, 9 minus 6 is 3.
You divide 3.
Yeah, so a lot of people want to just work this left to right. So Peyton, they would accidentally take 2 plus 3. But we are going to divide first. So 2 plus 1 is 3.
I knew it.
Yes, it's 3.
Okay, raise your hand if you can help me with the next problem. Tori, what do I do first?
Exponent.
Exponents. So,
No, you do the one that's first.
yep, we can actually do both because they don't affect each other. So, 3 squared, 3 times 3 is 9. And 8 times 8 is
24.
64. Okay, so I've got multiplication and addition. Raise your hand and tell me which one comes next. Madison? Yep. Multiplication, yep. So 12 times 9, anyone remember?
91.
No.
91.
No.
What?
108.
108.
What'd you get 80 and 91 from?
I got the answer.
Okay. Tori, when you add them both together, did you get an answer?
Got 172.
172. When you do step by step by step, you have a better chance of not making a mistake. Okay? Okay, so one little thing that I noticed when we took our like quiz or stuff like that, if I gave you guys a problem like this, let's say, okay, a lot of you thought that you should do the parentheses first. Okay.
That means multiplication.
Yes, so just for the sake of everyone on the video, if you guys just constantly yell out, it's going to be hard for them to hear it. Okay? So, yes, you are correct. We have to work this left to right. This just means multiplication. So we do have to divide first. This would be 9 divided by 3, which is 3, and then 3 times 2, which is 6. So just be cautious that just because of parentheses, I use parentheses, and you'll see parentheses used for just multiplication a lot. If there's nothing inside there, there is nothing to do with the parentheses. Okay, so this section was actually one of the ones that was requested, and I have some more problems that we're going to do too with the 1-5. So with 1-5, we had the different properties that we had to identify. So the first question here, we have 10, 13, 28 times 10 equals 10 times 13 times 28. So when the order doesn't change, we did not use the commutative property. So if we didn't use the commutative property, that means we've used a different one. But notice the position of my parentheses changed. Do you guys remember which property tells us that we can change the order in which we multiply or divide? Okay, Lydia. The associative?
Yeah.
Yep. So this one is the associative property. Okay, so sometimes we use this property if, for example, something might be easier to multiply. Like I would rather take 10 times one of our numbers first. This one isn't a great example of why they use it. It just shows it. Okay, then the next one. If you add 0, this is a 0 to something and it stays the same, which property tells us this is true? Kennedy. Identity property. It kept its identity. This is also true when you multiply by 1. Okay, and letter R, notice the order in which these problems are added together changed. Which property tells us that we can change the order as long as we're just doing all addition or all multiplication?
No.
Jaden. Yeah. Okay. And then this last one, which I had you guys do some practice with this one on the iExcel, it tells us that this is the same as this. Now, some people think that this is the associative property because there's parentheses. But just because there's parentheses does not mean that that's what property it is. Okay, Jada. Distributive property, because the 6 times x gives us 6x, and 6 times 4 gives us 24. Okay. Sorry, I was looking for those examples that I was going to do. We had some that we... Oh, here they are. Okay. So on these right here, it gave you 4 examples. This was something from our notes. And it wanted you to show what you would do to which properties you would use. So which ones would you group together? So for example, I might use, when I look at this, I would rather take 4 times 50. Does anyone know why I would take 4 times 50 first? Maddie?
200.
Yep.
A lot easier than mine.
Yes. So I would, like if I were doing this problem, I would use the commutative property to solve this. Okay? So I moved them around, and then sometimes they like to do this, even though we are going to do that first. So when I would tell me which property this is, first I use the commutative property, then I use the associative property. And then this, like you said, would give us 200. 200 times 9, that would give us 1,800 for an answer, and we didn't have to do anything really complicated. Okay. Number 6. Would you keep it like it is? If you're trying to do this mental math in your head. No. Lauren, what would you try to do?
Take 45 plus 7.
What would you say?
Take 45 plus 7.
Okay, so you could have, does 45 plus 7 make it any easier for us, though, do you think?
30.
I mean 33 plus
Yes, so you want to add these two together. So we do this naturally because we know we can, but exercising the property means that we might first change the order. Oh yeah, it can stay like that. You just switched where the 45 and the 7 were. I didn't need to move my parentheses because they were there. Okay, so this, we just use the commutative property. And then 33 plus 7 gave us a nice 40. 40 plus 45, that's just adding. So this gave us 85. Okay, the next problem. Let's see. Anyone want to change it? Peyton, what do you think?
40 times, or 5 times 40.
Yeah, why do you choose to do that?
Because that one is a lot simpler than the 40 times 7.
Yeah, so we just are going to switch the location of these two. So this gives us 200, and then that becomes a little bit nicer. Because 200 times 7 we can do in our head. 2 times 7 is just 14, and then you add those zeros. So this one was that commutative property again. A lot of times you can get away with just using that. Lauren?
25 times 14. Oh, no, that's good.
Yep. Okay, last one here. On this one, which two problems are maybe easier to add together? Joseph?
48, is that a multiple, no, 48 plus 15?
You mean 85?
Yeah.
Yep, so I would maybe switch the order of these. So I do 98 plus 15 plus 85. So that was the commutative property. And then I would, and I know that you guys do this just mentally, but this is just showing you how we use those properties. This is the associative property. So this would be 98 plus 100, which gives us 198. So a lot of people had questions on this section, so I hope that explains that a little bit more. Okay. Moving on to 1-6. On 1-6, we just had to evaluate. When I say evaluate, what is another word that we can use for that? Evaluate means to what?
Like
Simplify, or what's another word?
answer, I guess.
to answer it, to solve it. Okay, so if I tell you to evaluate, most of the time you're actually going to get an answer, which is what happens in these problems. So I gave you an expression. So an expression has no equal sign, but then I told you what A and B equaled. So A is 4,
This is 20.
and B is
This is 3.
3. I encourage you to rewrite the problem with those in there. So this would be 5 times 4 minus 6 times 3 plus 7. Order of operations tells us we need to do what? Well, parentheses, but remember the parentheses in this problem are just what? Multiplication. So Lauren, what am I going to do? Multiplication. So I'm going to multiply these and these together. So 5 times 4 is 20. 6 times 3 is 18.
Which will be 2.
Okay. So 20 minus 18 is 2. 2 plus 7 is 9. So make sure you do work those left to right. If you would add the 18 and 7 together first, you would be incorrect. Okay? Okay. The next problem, 6 is what x is equal to.
6.
So I have 4 times 6 minus 5. Again, what am I going to do first?
Multiply.
Multiply. So 4 times 6 is 24. 24 minus 5.
19. Good job.
Okay. Again, we have n equals 5 and m equals 2. So just to remind you that when a number and a letter are touching, they're multiplying. Some people forget that and they end up writing like 62 instead of 6 times.